Hello class, today what we're going to talk about is how to use chords of circles. Alright, so first we need to start with some properties and things about chords so that we can use them. Alright, so congruent corresponding chords theorem. What this says is that if in the same circle, or two congruent circles, two minor arcs are congruent if and only if the corresponding chords are congruent. So what that means is arc AB is congruent to arc CD if and only if the chord AB is congruent to the chord CD. Also, it means that if the chords are congruent, then the arcs are congruent. But also, if the arcs are congruent, then the chords will also be congruent. Alright. The perpendicular chord bisector theorem. So, what this is, if the diameter of a circle is perpendicular to a chord, then the diameter will also bisect the chord. Alright? And it has to be perpendicular. If it's not perpendicular, then it's not going to bisect the chord. And it also has to be the diameter. Okay? This is just the converse. This says if a chord is a perpendicular bisector to another chord, then that first chord must be the diameter. Alright? Okay, so let's take a look at this, see what we can do with it. So here we have two circles that tells us that they're congruent, and we can see that they're congruent because their radii are congruent. So that means the circles are congruent. And in these, chord FG is congruent to chord JK. And we want to find the measure of arc FG. Well, since the chords are congruent and the circles are congruent, that means the arcs are congruent. So since arc JK is 80 degrees and it's congruent to arc FG, FG is also 80 degrees. So that's simple enough. So here we want to find HK, and notice this has no symbol over it, so this is talking about the length of the segment. This is the measure of the arc. Okay. So we want to find the length of chord HK, and we want to find the measure of arc HK. Now the length of chord HK is pretty simple. Since this is perpendicular and it's the diameter, that means it's a perpendicular bisector. Alright? And so this is bisected, so NK is half of HK because it has been bisected. And so all I got to do is double NK, and we have that HK is 14 units long. The arc here is going to be a little bit more complicated, but not too much. The arc, if the chord is bisected by the diameter, the arc is also bisected by the diameter. And that means that this arc measure is the same as this arc measure. So we can set those two equal to each other to figure out what X is. Alright, so we're going to set them equal to each other. 11x equals 70 plus x. And then we solve this. So subtract x from both sides, divide by 10, x is 7. Alright. And then we can just take it, we can plug it into either one since they're congruent. Here we're plugging into the 70 plus x. 70 plus 7 is 77. And since it's bisected, all we have to do is take the 77 and double it to get the entire arc HK. So 77 times 2 is 154 degrees. So not too bad. It's pretty simple stuff. So what I would like you to do is answer these 4 questions. Pause the video, work them out, then come back and check your answers. Alright, let's see how you did. Number 1, the measure of AB is 110. We want the measure of BC. Well, it's all in the same circle, and we see that this chord is the same as that chord, which means the arcs are also congruent. So if this is 110 degrees, this is also 110 degrees. Number 2, what if AC was 150, not 110? It was 150. What's AB? Not going to be 110, different thing, different situation. Now we get 105. Number 3, you should have got 10. Number 4, you got 144. So hopefully that's what you got. If not, we'll work them out. We're going to work out 2, 3, and 4 real quick. So number 2, well, we have 360 degrees is for the circle. This much is 150 for AC. That leaves us 210 degrees for arc ABC. And since the chords are congruent, that means that the arcs are also congruent. So these are the same thing, adding up to 210. So we can divide by 2, 105. All right, CE right here. Well, since this is a diameter and it's perpendicular, it's also a perpendicular bisector. So CF is 5. Excuse me. FE is also 5. And so we have 5 times 2 is 10. Okay, number 4, a little bit more complicated, finding these arcs. The only reason that's more complicated is because they gave us expressions instead of numbers there. So first, we know the arcs are congruent because this is a diameter and it's perpendicular to the chord that subtends the arc. So what we have here, we set them to be equal to each other. Add the x, divide by 10, x is 8. Plug that back in to find the arc, measure of arc CD. So measure of CD is 72 degrees. And since the diameter is bisecting it, we can just double that to get the entire thing. And I've got stupid little pop-ups that are annoying me. Okay, here we go. So we're just going to double the measure of arc CD. So 2 times 72 is 144. All right. Okay, so let's take a look at this. This is the equidistance chord theorem. What this says is that if two chords are equidistant from the center of the circle, then the two chords will be congruent. Or if you have two chords that are congruent, then they are equidistant from the center of the circle. Remember, distance is found with perpendicular lines. Always has to be perpendicular to the segment that you're looking at. All right. So what we're going to do, in this diagram, in this circle, circle C, we need to find the radius. It tells us that QR equals ST, which is 16 units. And we got measure for segment CU, measure for segment CV. So if we look at this, we know two things right away. One, since this is the diameter and it's perpendicular to the chord here, this is being bisected. QU and UR are congruent. And second, since the two chords are the same length, QR and ST, that means that they're the same distance from the center, so UC and CV are congruent. Alright, that's what we know. We need to find the radius. So we need to find CW or CX or some other radius. Right? And what's actually going to be easiest here, instead of trying to find CW or CX, the easiest thing to do would be find CQ. Alright? Find this radius. Because now if you look, we've got a right triangle, and if we can find the lengths of these two sides, then we can use Pythagorean theorem to find the radius. Right? And we've already got some information about the lengths of those two sides. Right? So, first let's find CU. Well, since the chords are the same length, that means they're equidistant. So CU and CV are going to be the same length. So we can set those equal to each other. So 2x equals 5x minus 9. Move the 5x over here, divide by 3, negative 3 rather, and x equals 3. Right. So we take this 3, plug it back in there, and we got CU is 6. So we now know this is 6 units. Now we can find QU. Well, since this is a diameter, it's a perpendicular bisector, and we know QR is 16, so QU is half of 16, QU is 8. So here we have 8 units, here we have 6 units, and we can use Pythagorean theorem to find that. And if you remember, 8 and 6 are two legs of a Pythagorean triple, so it's 6, 8, 10. So QC is 10 units long, and that's our radius of 10 units. That is a bit more complicated than some of the other stuff, yeah. But it's not too terrible. You find these two sides, and then you can use Pythagorean theorem for the radius. Alright. And I would like for you to do that on this one. So pause the video and find the radius in this circle, then come back and see if you got it right. Alright, let's see how you did. So first we want to draw that radius in this. So here it is. We are looking for NK. That's going to be our radius that we want. because that's going to give us this right angle. And we could do NK, we could do JN, it doesn't matter. We don't want to do this one because this length is the one we're looking for. And we could do this, but the diameter isn't bisecting this, so we don't really know how long it is. So we want to use this chord here. Alright. So first we need to find x. So we know that 3x equals 7x minus 12 because these two chords are the same length, so they're equidistant. And we work that out, we get x equals 3. Plug that back in, and NP is 9 units long. Alright, now we need the length of PK. So PK is half of JK, because this is the diameter, so it bisects the chord. It's a diameter, and it is perpendicular to the chord, so it bisects the chord. And JK up here is 24, so half of 24 is 12. So now we have two sides of this right triangle. We can find that third side, in this case it's the hypotenuse. So Pythagorean theorem, our radius equals NP squared plus PK squared. So 9 squared plus 12 squared, we just substitute those in. Work that out. R is the square root of 225, which is 15. And there's our answer. We have a radius of 15 units. All right. So, not too bad. I would like you to do one more. This time we're going the other way around. All right. So this time it wants to find how far is this chord from the center of the circle. So pause the video and work that out. All right. Let's see how you did. You should have got an answer of 5 square roots of 3 centimeters or 8.7 centimeters. All right. Same thing. If you didn't, this one's a lot easier. You're going to use Pythagorean theorem again, but this time they gave us the hypotenuse, and oh, we don't want to use 10. This distance here is going to be coming from the center, so this is a diameter. Kind of, this is going to be coming off of the diameter, so it's perpendicular. So perpendicular bisector of the chord, so I'm going to be using 5, half of the chord. All right. So we've got 75 equals d squared, so d is the square root of 75, which is 5 square roots of 3, or approximately 8.7. All right. Hopefully that works. Not too bad. I hope you found this helpful, and I will see you next time.